Hi all, myself Mr. Manideep Gupta, Assistant Professor from Department of Aeronautical Engineering, MLR Institute of Technology. Today the topic which we are going to discuss is about the solid propellant rockets. Solid propellant rockets. Coming to the overview of today's presentation, we will discuss about what is the introduction, what is solid propellant and types of solid propellant rockets, and coming to that, classification of propellant grain configurations based on loading strategies, and also we'll go through the grain shapes. Coming to the introduction, this is the solid rocket motor cut section. Okay, here you can see the cut section of the solid rocket motor. And coming to the components, these are all the components, okay, components of the solid propellant rocket, main components, not including all components, as main components. Here you can see this part is the igniter. Okay, if you observe, it is a cut section. That's total like a cylindrical grain. If you see the motor case like this, if I cut and view from the top, then it will be visible like this. Okay, and this is here you will place an igniter. Okay, this is the igniter, and this is the nozzle. This is the nozzle, and if you observe, the nozzle has a liner here. Now this here, the dotted one is the nozzle liner. Okay, and here you can see the nozzle closer, and whatever this layer here, it is insulation, and this dashed line you can see here, these dashed lines on the both sides. Here you can see the dashed lines. This is a hatched portion, right? This hatched portion is nothing but the solid propellant grain. This is actual your propellant. This hatched portion is the propellant. Okay, the propellant shape here, if you see the total propellant grain shape, it is like this. It is a hatched line. This is the shape of the cross section view, cross section of the propellant grain. If you cut this propellant grain like this, and we are watching the propellant grain like this in the rocket motor case. And next, whatever the outer portion, this outer layer, okay, this outer layer is the motor case. Okay, and next there is a layer between the case and insulation, that is liner. Okay, so first one is outer portion is case, next one is liner. Okay, after that you will have insulation, then the fourth one is propellant grain. So if you take the motor case like this, this is a first layer, this is the motor case, second layer is the liner, the third line is the insulation, and here you can see this is the propellant grain. Configuration, nomenclature, different nomenclature. What is configuration? Coming to solid propellant motors, we say configuration means the shape of the geometry of the initial burning surface of a grain as it is intended to operate inside a motor. So configuration is nothing but a geometry of the surface, propellant surface grain. Okay, like next cylindrical grain. A grain is which is the internal cross section and is constant along the axis regardless of perforation shape. So grain is nothing but the cross section. Okay, a cross section of the propellant grain. Cylindrical grain is a internal cross section of the propellant, solid propellant grain. So perforation, the central cavity part, okay, flow passage of a propellant grain. Its cross section may be cylindrical, a star shape, and others. So perforation, if you take the propellant grain like this, it can be a cylindrical perforation like this, and it can be a star also. The central cavity can be any shape. Sliver, the unburned propellant residue or the propellant lost, okay, expelled through the nozzle at the time of wet burnout is called sliver. Coming to the classification of propellant grains based on loading strategies. So based on loading strategies, the propellant grains are classified into two types. One is cartridge loaded or freestanding grain. Another one is a case bonded grain. Okay. So based on loading strategy, if you take a rocket motor, how you are placing the propellant inside the rocket. Okay. That is based on that it is two types. Cartridge loaded or freestanding grain. You can see in the diagram in the figure here this red color one is the propellant grain. Okay. And here you can see the cross section perforation shape is a star propellant grain. It is a star propellant grain. What they are doing is they are making this propellant grain outside the rocket motor case and they are placing this propellant grain in the rocket motor. So that is why it is called cartridge loaded or freestanding grain. Whatever the propellant grain made outside and loaded into the rocket motor. Then that is cartridge loaded or freestanding grain. Next type is case bonded grain. What we do is in the rocket motor itself, we pour the powder, we mix the resin and we make the propellant grain in the rocket motor itself. That type of propellant loading strategy is called case bonded grains. Those are case bonded grains. So coming to the difference, here you can see the cartridge loaded grain. Here you will have one forward support and here you have one flange. This is the flange and rear support, and in between there you have insulation. You can see the nozzle. Okay, and whatever this is your cartridge. Okay, this is your grain. Okay, coming to the cartridge loaded. So the manufactured separately from the case. We make the grain outside by extrusion or by casting into a cylindrical mold or any method. So loaded into or assembled into the case separately. Cartridge loaded grains are used in some small tactical missiles and few medium sized motors only. If the rocket motor size is small, then we can use cartridge loaded propellant grains. But if the motor size is very high, then it is difficult to, you can make the propellant grain outside, but it is difficult to load in the motor case because the weight is very heavy and while handling there is a high chance of damaging to the propellant grain. So that's why we go for case bonded grains for the heavy rocket motors. So for small rocket motors, we can use cartridge loaded grains used for small tactical missiles and few medium sized rocket motors. So they often have a lower cost and easier to inspect. We can easily inspect the propellant grain for a cartridge loaded type. Next one is a case bonded grain. So what we do in the case bonded grain, right? So case bonded grain, the case is used as a mold. The case, what are the rocket motor itself used as a mold, and the propellant is cast directly into the case and is bonded to the case. Propellant is casted. Okay, it is directly in the case. So then it will have liner and insulation. Everything will be done in the motor case itself. Okay, so freestanding grains can more easily be replaced when compared to the case bonded grains. Suppose if the age of the case bonded grain is over, then we have to remove the total grain powder from the motor case and we have to cast the another thing. Coming to the freestanding, we can easily remove the propellant grain out from the motor case and we can place the new one. So changing is very easy for a freestanding grain compared to the case bonded grain. But for large rocket motors, we cannot use freestanding. We should go for case bonded grains. So case bonded grains give better performance when compared to the freestanding grains, but more difficult and expensive to manufacturing. So time taken, process. Okay, the process for case bonding grain is high when compared to the freestanding grain. It is difficult. It is difficult and expensive also. Next, coming to the grain shapes. I have gone to the configurations, right? In that grain shape, different shapes. Here you can see cruciform grain. Cruciform grain. Whatever this portion is nothing but your propellant grain, and the remaining one is a cavity, hollow portion. The shape of the grain is cruciform, and this is a star grain. The cavity shape is star, and it is a cylindrical grain. And next, anchor. The cavity hollow portion is like an anchor. Next, tubular grain. Okay, the propellant burns from the inner surface and also from the outer surface. So you have cavity inside and outside of the propellant grain. So both inner surface and outer surface both are exposed to the combustion heat. And here you can see another type of grain shape, that is rod and tube grain. Okay, well, some of the grain is placed inside and a small gap, and again we have grain propellant. Okay, so the propellant burns, more propellant burns at a time. So here this propellant burns from the outer surface, and at the same time this propellant burns from the inner surface. So at a time, the here it is different, both are in opposite. Okay, so to produce large thrust we can go like this. And next, end burning propellant grains. There is no cavity, the motor case will be like this. The propellant is filled completely, the burning starts like this in the motor case. Then this is the end burning. And next, dog bone. The cavity is like a dog bone, wagon wheel. Like this, different types of grain shapes are there. Depends upon the requirement. Requirement in the sense, what type of requirement? Depends upon the thrust profile you need. How you want, how to change the thrust. See, the difference between solid propellant rocket motor and liquid propellant is, the solid propellant rocket motor thrust profile cannot be changed immediately like a liquid propellant rocket. In a liquid propellant rocket motors, we can control the valves, fuel flow rate, and we can increase and decrease the thrust like our wish. But coming to solid propellant grains, depends upon the thrust profile, you have to design the propellant grain shape. Suppose you want to continuously increase the thrust, you should go for propellant grain like this. You want to the thrust to be decreased with respect to time, then you should go to the propellant grain like this. And if you want constant thrust for the rocket motor, then you should go for end burning like this. Like this, based upon the requirement of thrust profile with respect to time. Either thrust has to be increased with respect to time, constant or decreased. Based on that, we will go for different shapes. Okay, even we will discuss the thrust profiles of these all grains in the next lecture. So this is about the introduction of solid propellant rocket motor and the grain shapes. Okay, coming to the summary. So we have gone through the introduction, what is solid propellant rocket motor, and the classification of propellant grain and grain shapes. Thank you.